So again, today's gonna feel like we're just reviewing parallelograms again because that's what we're doing in this case. Just trying to make sure we understand all the different properties of parallelograms. And I kind of like separating these two lessons so that maybe it sticks a little firmer in your memory when we kind of break them up as two separate days, or as a few days in between even. So you may be watching this at a different time, so just a heads up on that. So in our parallelogram, we know a lot of different things about the shape. What do you guys set up first? I know a lot of you guys got going on this already. What part of it did you do first? Yep.
I found X first.
Okay, so you found X first, and we know that the opposite sides of parallelograms are equal. So what equation did you write?
21 equals 6x minus 3.
Yeah, so we're able to solve an equation for X because those opposite sides are equal. And so sides are on the outside. Typically I try with angles to put the degree symbol to show you it's an angle. So these are talking about sides, so those two should be equal. And so I find out X is 4. I would probably suggest going for Y next since we're on that wavelength there. So we have another equation we can write for Y. We're going to move that 6 over. And so we find out Y is 3. So we found our X and our Y. And then we get an equation like this as one of our homework quizzes with the angles. I think that gave some of you guys a little bit more trouble. So in terms of the angles, you probably have to go for A first. So, and remembering with the angles of a parallelogram or some of the other shapes we've talked about, because this works in a trapezoid as well in this way, those two angles together should add to what?
180.
180. So they're considered supplementary, so those two together add to 180. So remove the 10 over. So 2A equals 190, so I divide, and I find out that A is 95.
Yeah.
Is that what you got? Now, sometimes in these drawings, it doesn't look maybe exactly like 95, but we just gotta go with it. So this would be 95. Now that I know that, then that and this B value should together add to 180.
I can just throw it in the equation.
Oh yeah, that'll work too. Good call. So let's point it out here that we could put this back in here to figure out this is 85. And then those opposite angles are equal. So B is also 85. That's a little quicker. Good call. Right? Yeah, that'll add up. Any questions there? Okay, so again, talking more about parallelograms. Now the way they kind of explain this section is this is the opposite of what we did the other day is we knew it was a parallelogram, so we use all the properties. These are basically saying how do we show that it's a parallelogram for sure. So understanding that and being able to classify it that way. I actually feel like we have this question already.
We did.
Shoot. Oh well, we'll still do it. It's okay. I don't know how that ended up happening with my notes. Oh well, we're gonna have to go with it. All right, so this LSH is 110. XLS is 30 degrees. And RX is 5. They want us to find SLR. So SLR is this angle here. And again, kind of using our warm-up from the other day or our warm-up from today, we know these together should add to 180. So that would make this 70 degrees. Now they want us to find XLR, and we talked about the fact that in parallelograms, those angles aren't necessarily bisected. So the other one can't just automatically be 30. That's a really common response because it kind of looks like it could be the same. But we know if the whole thing is 70, these together have to add to 70, so 30 and 40 would give us that 70 degrees. And then RS is all the way across, and we learned last class that parallelograms bisect each other, or the diagonals bisect each other, so that would just be 10. Yeah, I don't know how this happened with the notes, but I don't think it's bad for us to review, so we're just gonna review. So in this part of it, we talked about this last time, so do you guys remember what we used to find the intersection of the diagonals? We use that midpoint formula. So if you guys want to take a minute to do that, our midpoint formula is the intersection of the diagonals. And when we talk about this and we go to name this shape, I just want to make sure I'm finding the right midpoint. So if I start here naming it R, S, T, U, I'm trying to find the midpoint of either RT or SU. It should be the same exact point. So I'm going to find the midpoint of SU. So we're going to find that midpoint. And so we're going to add the x's together and divide by 2. So negative 6 and 4, and divide by 2. And then 7, and then negative 2, and divide by 2. And so just reminding us that we can find that midpoint because it's where those two lines cross.
This one's missing.
What's that?
This one's missing.
Yeah, I don't know what happened there. It's like I said, it's not bad for us to review, so that's okay. With my other classes not having me here tomorrow, it's kind of not a bad thing to just kind of do some extra practice of the same stuff. All right, so we're gonna flip the page over when you guys are ready, and we're just gonna list all the different properties of parallelograms kind of in one place. And then we'll just have some time to work on homework. Homework is a little bit longer, again, especially since our notes are probably pretty quick here. That's probably an okay thing. So we learned 5 different things about parallelograms. And it's okay at this point if you do have to look them up, like if you don't remember them all. But at the same time, at some point, we need to have these all memorized. Now, you don't have to like regurgitate them and say like rattle them off. You have to be able to use them. So when you see them, you have to be able to say, yeah, I know what that is. So like that you'd be able to like tell me all those different properties. So first property you guys want to list, what'd you list? What'd you write down? Yeah, so there's 2 sets of equal sides. And I drew a bunch of parallelograms here, so we're not marking up the same things on every single shape here. Sometimes that gets really convoluted and it's hard to see what's going on. So if I have 2 sets of opposite sides that are congruent, equal, that means that it's automatically going to be a parallelogram. Somebody else give me something else. Yeah. So the opposite angles, yeah, so 2 sets of opposite congruent angles. good. So again, if you know that, literally if I draw you any shape that I show you that, you can see already that's a parallelogram. It has to be. What else do you guys know? Somebody else? Yeah.
The opposite sides are parallel.
Opposite sides are parallel.
Two base.
Yeah.
The bases on it.
Yeah, so they're always opposite of one another because that's kind of the definition of parallel. All right, we got two more rules. One's about the diagonals, and another one is about the, oh, actually, we have one new one. So we're going to talk, the next one's about the diagonals. And then one is going to be a new property that we didn't realize before that actually proves that it's going to be trapezoid. Yeah.
A plus B equals 180.
Yeah, and I'm going to kind of break that up in here because that one's a little bit tougher to prove it. So like, remembering that these two are supplementary. So these each equal 180. Alone, I think that's a rough rule to just use because of the fact that a trapezoid kind of has that as well. Now a trapezoid doesn't have two sets of that going on, so that makes it a little bit different, but that's not a rule kind of on its own. So I'm gonna not put that one there for a reason. The one I wanna mention is the diagonals. What happens to the diagonals here? Yeah.
They get cut in half.
They cut each other in half. So they bisect each other. And I would have forgotten about this last new rule, so I'm glad I looked up my notes. Because this last rule is a weird one, and this one is enough, and you could add it as 6, you're technically not wrong with yours, that's fine, but so see, I already filled in 5 of them that we already knew. This new one is just one that's kind of like, strangely, that this always works. So if I have one pair of opposite sides that are parallel and congruent, it's automatically a parallelogram. So if these sides are equal, but they're also parallel. So you might be asking yourself, well, wait, doesn't a trapezoid have that? No, because a trapezoid has a parallel sides, but those sides are never equal when they're parallel in a trapezoid. So the difference between a parallelogram and a trapezoid is kind of that rule. That's how we distinguish the difference between those two. So if those sides are equal, they automatically, and they're parallel, they automatically have to be a parallelogram. All right, and then our last thing for today is just showing that this shape is a parallelogram. And so we're gonna draw it. And then our homework, like I said, is a little bit on the longer side, but I'll look at it and make sure we're gonna keep it that length. But we also have this big chunk of time to get homework done. So let me see where we're at. And we might need some graph paper for this. Oh, I'm like, the way I first drew it, I'm like, that is not a parallelogram, and then I realized I had a point in the wrong spot. All right. So they're saying, show that this is a parallelogram, and I'm telling you it is. Remember, what do we need to do in order to check that it's a parallelogram? We did this with a trapezoid the other day, but this is a little more entailed, yeah.
Slope.
We have to check the slope. And we have to check the slope, like, so in a trapezoid, we only had to check 2 of the sides if the slopes are the same. Here, we're gonna have to check both sides are opposite and parallel. You could either do that, or you could also check slope and then check if one of the sides are equal. I'd probably stick with doing 2 slopes. So if this is F, G, H, J, I'm gonna check GH compared to FJ, and then I'm gonna check FG compared to JH. And you don't have to draw it, I kinda just do a quick little rise over run. So like GH is down 1 over 2, and then I check it here down 1 over 2. That's kind of how I knew I had my point in the wrong spot, because I was like, wait a minute, that didn't work. And it was a way for me to check that. Same thing for FG. Here I'm going to check 1, 2, 3, 4, 5, up 5, over 1, 2, 3, 4, 5. So these slopes are both 1. And so this would be a parallelogram. All right, let me check on the homework. And check, see if we need graph paper or anything like that. I'm wondering if we did some of this homework already. Let me check.
Yeah, some of it.
Yeah, it looks, some of it looks familiar. Let me see. (23 through 29), is that what's on there? Oh, and the 16, yeah, so we don't need that first half. Look at that. Just got a whole lot shorter. So we're just doing the second half, but do notice it does say all for those. Okay?